Alright, so basically the question says the diagram shows a wire of a diameter d and the length and the length L. Wait. So basically question says that diameter d and length L is that is firmly clamped at one end between two blocks of wood. A load is applied to the wire which extends its length by x. So we are given with block and the wire and load. There is another scenario. We are using a second wire is made up of same material. This is very important that you should know that it is made up of same material. And it says that it has a diameter of 2d and length of 3l. Both wire obeys Hooke's law. So this is very important information given. So what is the extension of the second wire when same load is applied? So basically जो load हम इधर use कर रहे हैं वही load हम इधर भी use कर रहे हैं second wire में. So what you will do is actually first of all you should know that we will use the formula of Young modulus. Young modulus का formula is actually stress over strain. Stress over strain. And we know that stress is force over area. So when we are discussing the first scenario, so we will say that force over area is actually F, the force F over area. Basically we know that pi r square is actually the formula for area, but when we replace r with d, we say it's actually pi d over 2 square. So we can write it as pi d square over 4 divided by strain is extension over length. So extension is x over length L. Extension is x and length is L. So this is actually we have actually calculated y in terms of all d, f, x, L. So now we will consider the second wire, in which y is equals to stress over strain. The force acting is same because load is same. They're saying that same load is applied. So you will say force over the area will be like because now you have 2d diameter, so you will write it. Let me see. When we write pi 2d square over 4, when you have to like this. So it will be like pi 4d square over 4. So 4 and 4 will be cancelled. So your area will be like pi d square. So you are actually taking the cross-sectional area, you know, the cross-sectional area of wire. So pi d square over the extension is now so we have to find extension. So we can say that we assume extension as a. So I can write that a over a x, whatever you can suppose, and length is 3n. So now you should know one thing, that if it's made up of same material, it means that Young modulus is same. Young modulus for both y is same. So Young modulus is same. So what we can do is we can actually equate these, like we can equate this expression with this expression. So wait. So I can write it down as f over pi d square over 4 over x over L. So we get to know that this f and f cancelled out, and we know that pi d square and pi d square are cancelled out. And now we can write it down as x. We can take x over L here, and we can write that down as, just wait, let me rearrange ताकि it do not create mess. I'm just rearranging this expression. Now you can actually do it more easily. Let me cancel F with F, L with L, pi d square with pi d square, and we have to make A the subject. So we can write it down. Just wait, let me erase this. I can write it down as 3x. I will take this x up and this 4 down, and this is the expression, or you can say this is actually the answer. So your answer will be B. I hope it's clear.